In this video, we present our work LoopGNN, Visual Loop Closure Detection through Deep Graph Consensus. The task of visual loop closure detection has traditionally been approached by retrieving camera images being similar to a query image using visual place recognition. This required compute-intense pairwise validation of retrieved frames through geometric verification utilizing ransack. Especially in unstructured environments, the degree of perceptual aliasing renders loop closure detection a very challenging task. We find that the majority of previous works integrated into visual SLAM pipelines utilize classical keypoint matching and geometric verification. All previous deep learning-based approaches utilize a pair of two camera images in order to identify a loop, which is prone to fail. In our work, we make the following contributions. First, instead of relying on a pair of frames as done before, we encode neighborhoods of similar frames given a query frame obtained via place recognition. Second, we introduce a novel graph neural network called LoopGNN that estimates deep graph consensus given a similarity clique in order to identify loops. Third, we evaluate our proposed on two distinct datasets and delineate the computational advances of our approach over both classical and deep baselines. Lastly, we propose a dataset split of the Tartan-derived 2 dataset suited to visual SLAM research. In our approach, we first obtain keypoints and descriptors for all camera images on the training set in order to fit a VLAD-based place recognition database. During inference, we obtain a query frame and retrieve a set of closest frames using the VLAD-based global image descriptors. Given a set of keypoints across all camera images, we craft a keypoint descriptor matrix that is fed through a NetVLAD layer in order to produce preliminary node embeddings for each keyframe extracted along a robot trajectory. Next, we create an interconnected, undirected graph among all retrieved keyframes, thus obtaining a maximum similarity neighborhood. Given the graph structure, we exchange information among the neighborhood using multiple chained graph attention layers. Finally, we obtain edgewise binary scores denoting loops. We retrieve the highest scoring set of edges and validate pairs using classical ransack-based geometric verification and obtain relative camera poses. We demonstrate that LoopGNN is more robust to perceptual aliases compared to previous deep and classical baselines on the task of loop closure detection as evaluated on the Tartan-derived 2 and NCLT datasets. In addition, we find that by only considering the highest scoring edges predicted by LoopGNN, we can drastically decrease the amount of image pairs that need to undergo geometric verification. For more details and supplementary material, please visit our project website. Thank you for your attention.